So when we talk about sequences, a sequence is some sort of list of numbers or terms, and an arithmetic sequence. So our arithmetic sequence is going to be some sort of number where the difference between the consecutive terms is always going to be the same. It's always going to be some sort of common difference or a constant rate. And we will always call that, just so we don't get confused, we're going to call that difference D. Okay? So our D is our common difference. If we look at the example we've got here, we've got a sequence that goes 4, 9, 14, 19, 24. We can see each of these, if we add 5 to the term before, we'll get the next term. So we know we have a arithmetic sequence here because the sequence is constantly being increased by the same number, and our common difference is a 5. The only other key point that we want to look at here is this 4. Because when we go to write our equations, we need to know what the initial value is. So the initial value is the first number of the sequence. So since it's arithmetic, we're going to call it A, and it is the initial value, so it is the first step of A. Okay? So now when we look at an arithmetic sequence in terms of the formula, we can write it in two different ways. We can either write the recursive formula, which means to find whatever term I'm on, I take the last term and I add the common difference. Okay? So if I knew, let's say I have the terms 1, 3, 5, 7, and 9. Right? If I want to know what the third term is, which is a 5 here, this formula says in order to find the third term, I just want to take the second term and add the common difference. Which means I would take the second term, which is 3, and I would add the common difference, which is 2, and it gives me 5. So this is very helpful if we know all of the terms, or even if we know the term before it. If we don't know the terms before it, this formula isn't quite as helpful. The other very important thing we want to always include with our recursive formulas is we want to put our initial term in there too. We want to say what our initial term is equal to. That way, even if we have to go all the way back to the beginning of the term, the beginning of the sequence, we can eventually find out what a certain term is. Okay, and now that's compared to the explicit formula, and like we talked about in class, the explicit formula is more like our linear relationship. So we can plug in the step or the variable. Here, n is our variable or our step. We will plug that in right here, and it will tell us exactly where we're at. So if I look back over here at the example where we have 1, 3, 5, 7, if I want to write the explicit formula for that, I could say that any step is equal to this A1 is my first term. We just said the first term is a 1, plus n minus 1 times d, which is my common difference for these ones. My common difference I'm adding 2 each time. So my common difference will be a 2. Now if I want to go through and actually solve this, if I want to find out what a of 3 is equal to, I'm going to do a1 plus, and now this is where I plug this in, 3 minus 1 times 2. 3 minus 1 is 2, times 2 is 2, plus 1 gives me a 5. So I can say that a of 3 equals 5. And I can see that here my third step is equal to a 5. Okay? So if we just go through these real quick, a of n is the nth term of the sequence. That's like when we're plugging in our variable. A of 1 is the first term in the sequence. A of 7 is the 7th term in the sequence. It's just a way to represent an n term. So we give a variable to that so that we can write it generically. A of 1, we already talked about, is the first term in the sequence. N is which term I'm looking at, or which step I'm looking at. Am I looking at the first term, the second term, the fourth term, the ninth term? Okay, and the other big one we want to know is the common difference. The common difference is how much of those increasing or decreasing per term. So consecutively, how much are they increasing or decreasing? This one here, my common difference was a 2, because we're increasing by 2 each term. And the last thing here, we'll just go through a quick example of how to write the formula, or how to write the function recursively and explicitly. We'll start recursively. Recursively, we can see here a of n and a of n minus 1. Anything where there's an n in there, we want to keep that variable, because that's what makes it a formula. We can plug in a value for n if we know it. If we don't, we just want to write a generic formula. And then the last thing we have to plug in is our d, or our difference. We can see here for this, our differences, they're increasing by 2 each time. So I'm going to put plus 2. Now, so what this is telling me is to find any term, all I have to do is take the term before it and add 2, which holds true. If I want to find the third term, which is 6, I can go to the term before it, which is 4, and add 2. So it always counts. Now, the other thing we want to put when we do a recursive formula is we always want to put that initial value. So my initial value for this one is a positive 2. And that's it. That's my formula. For a recursive function, it's 2 lines, and it's that simple. For the explicit function, remember the explicit function is more like our y equals mx plus b. The explicit function, we need to know the initial value, and we need to know our common difference, or what it's increasing each time. Okay, so a of n, again, anytime we have an n, we want to leave it in terms of n. a1 in this case is my initial value, that's a positive 2. n minus 1 stays as n minus 1. And my d value, my difference, is a 2. Okay, so that's it. That's all there is to writing explicitly. I want to know my initial term, so this is my a1 term, and I need to know my common difference, which is a2. Really, that's all there is to it. Explicit formulas, we write one function. For our recursive formulas, we always have to write 2, because we always have to include that initial value.